law. These are the materials for our experiment. This is how it works with a small coin. Now, this is the same footage but in slow motion so you can see what's happening. Again, but with a bigger coin. Again, the 100 pesos coin in slow motion so you can see what happens when we hit the plastic card. This happens mainly because if we abruptly remove the card by hitting it, the coin doesn't have enough time to receive a speed to go with the card. The card which receives a direct hit has time to slide, but the coin, who's being left without support, falls vertically into the glass by the gravitational attraction.
We'll ask, what is Newton's first law? Well, this law says that objects tend to keep on doing what they are doing, unless acted upon by an unbalanced force. For example, if we have an object and this is in a state of rest, this will continue in this same state of rest. Also, if we have an object that is in motion with an eastward velocity of 5 meters per second, they will continue in the same state of motion. There is a condition that will define this first law to be applicable to any given motion. This condition uses the phrase, unless acted upon by an unbalanced force. As long as the forces are not unbalanced, that is, as long as the forces are balanced, the first law of motion applies.
One application based on Newton's first law that states that an object in motion or rest will stay in motion or rest unless an unbalanced force acts upon it. For example, seatbelts are related to this principle because when we don't wear a seatbelt when the car comes to a quick stop, our body moves forward and stays in motion until unbalanced force acts upon the body. In other words, the unbalanced force is intended to cause a change in the object's state of motion or rest. You wouldn't stop motion unless a force is caused to change your motion and put you at rest. If you were wearing a seatbelt, the seatbelt will act as an unbalanced force because it will stop you from being in motion.